Hello and welcome to this webinar provided by Trimble. So I'm going to talk about what I call federated and linked approach to BIM data management and BIM-based workflow in construction. This will be a pretty conceptual presentation about a reasonable way to transform the construction industry from a human readable paper-based document-based process to and workflow to BIM and data-driven workflow. So we'll start with a few facts about myself. I have been working about 43 years with Tekla now, and Tekla was acquired by Trimble in 2011. And my background is that I have done every job there is to do in the software industry, both technical and commercial. So I've done programming, operation, product management, and also sales management, general management. And I'm pretty unique in that sense that I have spent about half of my career in the geospatial world and half of my career in the BIM world. So I have worked professionally for a long time with both. And my job currently is to be a Trimble standardization lead. So I represent Trimble in most of the standardization that has to do with data, mainly working with building smart OGC, ISO, and SEN. Okay, then we go to business. As I'm the BIM ambassador, my title is, so I get to tell you what BIM is. That's a privilege I have, and my explanation of BIM is quite simple. It's not, you don't need any complicated explanations. It's a part of the whole world being digitized. So the big deal with BIM is that is the transformation from human readable documents to machine readable data which can be used by software directly for input without human intervention. With documents, drawings, lists, and other traditional ways of conveying information, you always need a human convey or reading, understanding, perceiving the data, and then acting upon it. The difference is with structured model-based data that software can use it directly without human intervention, which gives a huge potential for more effective operations and doing things faster, better, and more effectively. So that's a pretty simple explanation. And this has some very big implications because in the human readable document world, the creator of the data decides how it's going to be consumed and decides the presentation of the information. So that's very specific to human readable documents. But now in the new digital world where we have model-based and machine understandable data, the consumer can decide how he wants to use the data and how he wants it presented. And that's happens by using software. So the user doesn't interpret the information directly. He uses software to enhance it and change the presentation. So in effect, we can separate the content of the information and the presentation of information, and the user defines the presentation. And this is a pretty big change in the process, which requires plenty of new software and new learning. I'm coming more to that later on in the webinar. One interesting fact happening is that the focus in BIM software is shifting from data creation to data consumption. So today we have a situation where about 80% of the software is for data creation and maybe 20% for data consumption. And in the coming years, that will reverse, so that the most of the software will be data consumption for data consumption, and the smaller part for data creation. And the data creation continues to grow. And for that, we need, of course, plenty of new software and new learning, and we have many things. This is also interesting in the sense that until now, BIM has touched very few people in the construction process, because it's only those who have created data. With this focus shifting to consumption, it will touch everybody in a construction project. So this will really proliferate BIM into the construction process. And the theme of this presentation is how that should happen, how and why that should happen. And the new software will mostly be based on the CDE, Common Data Environments, or what I like to call them publishing platforms. And I will come more into that later on also in the presentation. So how from the origins of BIM, how was this thought to work? How was the idea that the information would be managed and handled and shared by others? The original idea, specifically with IFC, but also with many others, was that we have the model. We have one single source of truth where everything is stored and shared by everybody in the project. The idea was that this single model just evolves from the early phases of the project to the actual representation of what was actually being built and facility management. But this has proved to be impossible to do for many reasons, both technical and not least, or I would say more commercial and legal reasons than technical reasons. And the general thing is that the market is more and more releasing this, and we need a new concept on how to do the workflow, how to do the information sharing and information management. And this is what this presentation is all about. So, but in the general public, with this, I mean, of course, construction trade public, there is now no real concept on how to address this. So the kind of core of the idea which I'm presenting is something I would call productivity BIM. So there are already signs in the industry when BIM is mostly used for collaboration, or collaboration is kind of more or less the driving factor of BIM, that it's perceived and experienced as a burden on the process. And when the consumption of data still is mostly with drawings and human readable documents, the kind of promise of BIM to be more effective and more useful hasn't been materialized. So to remedy that, I'm promoting a concept where every party in the construction project models what is their added value to the project. So everybody creates their own model, which they own and which they share with other people, and share by using publication, not kind of direct sharing. And here contract borders are very important, because within a contract border, where you have the participation in the project is defined by one contract, you can do almost whatever in terms of information sharing. But when you go across a contract border, you can't do that. You have to be more formal in your information sharing. You have to have traceability. You have to have revisioning. It has to kind of be more controlled and more formal. And also it needs to be court compatible. I say lawyer compatible, so that you have, if you go to the court with your contract, you have some proof and some material to show to the judges and lawyers. And the idea here is that the collaboration aspect and communication is mostly a byproduct. It's collateral damage from you doing your daily work. So you use BIM to control and optimize and make more effective your daily work. And as a byproduct, you also get the collaboration aspect to be used by others. And this has been how technostructures has been used from the beginning in the industry. And technostructures is a good example that this can really happen and has happened. And also the technostructures models have a very good reputation in the market, exactly because of this reason. because when you model for your own use, you have a very high incentive to make the model good quality so that it's up to date and it's correct. And that's what happens with Tekla structured models, and that's why they are so popular in the market, and people want to use Tekla structured models because they can be trusted. And trust is a very big issue in the whole model-based world. So then a few words about modeling in general. So my motto is that there is no such thing as the model. So neither as a model instance nor as a schema or say, let's say the content on what types of objects you have in your model. The reality is just too complex to model as with one representation. So for different purposes, you need different representation. And this comes to that the model is always based on an abstraction of reality, because we just can't model the reality as it is so that it would serve all possible purposes. And this situation is, and in my opinion, will stay for the foreseeable future. That's not going to change anytime soon. And this idea has also one more implication, and that's an abstraction. In the concept of abstraction, it's included that it's made for a purpose. You don't have kind of general abstractions, then it's just a summary or abbreviation, but an abstraction you in practice have to make for some specific purpose. And there we're coming again that we need several representation. This is elaborating a bit on that idea that we have different viewpoints, use cases, and the same objects can't serve them all. We need different objects, representations for the same physical phenomena. And they are not by any means one-to-one objects. So you have many-to-many relationships between these objects types. And you have functional objects, which typically architects use, which are describes the facility from a functional point of view, how it serves, how it looks, how it serves its users. You have physical objects, how it's going to be built, but then also you have logical objects, which are kind of constraints that you have to be able to say that this angle needs to be straight. Whatever changes, this angle will always needs to be straight, and all kinds of other constraints which you can have model. And you have fully abstract objects which are not in play. I would call them non-kickable objects. They are objects which directly don't exist in the reality, and the space is the most typical of these object types, which is an abstract which you can't touch, non-touchable, non-kickable objects. And space is, by the way, the most important object type in BIM. You use it all the way from very start of the early scale briefs of the project up to facility management, and all the way to dismantling the facility which you are modeling. And you also have objects describing the process and progress, not just the physical things, also process describing objects these days more and more. And this is a bit more concrete example of what I mean. So an architect would typically represent a slab, a floor in a building as one object. For the engineer, it might be 3 objects, 5, 10 objects, which is what are the structurally functional objects. And for detailing, the same thing might be 10,000 objects. And an architect can't do his job with the detailers objects, and vice versa. You have to detail if you want to use BIM for all throughout the project and have a constructible model and as-built model in the end. And so you need these to exist and coexist, and they need to be updated all throughout the project. So they need to be updated. You need all of these representations all the way to facility management and dismantling of the facility. So in the new world, new truth, you need all of these 3, and it's not limited to 3. It's more, many more representations than you would have in reality. So then we come to the actual information management, information sharing, and workflow This is my concept. I call it federation and publish-based information architecture. And the fundamental idea here is that you don't try to cram everything in a single model. You keep the separate models. And the basic idea is that every party models themselves creates objects which they own and which they share by others and use that. And for that, we need to separate the application live data, which is in an application specific schema, which is created, stored, and managed separately from the published data in standard schemas, data which you in essence receive from others, from other parties in the project. An important point here is specifically for Building Smart and the standards community that which I have been promoting already for years and promoting more and more strongly is that you consume the information you get from others in standard schemas directly. You don't bulk convert that to the native schema. You keep it in the standard schema. So instead of talking about importing IFC, we talk about opening IFC. You just open an IFC model you have received from somebody, and then you can use it together with your native data so that they are merged on the screen and in the application functionality in different because the requirements are different. For that to happen, we need a new software architecture, which I call multi-kernel architecture. So the simple thing is that your software kernel needs to be able to consume data in several schemas. It doesn't need to create data. It can create data only in one schema. Which is then published in the standards schemas, but it needs to be able to handle as input for the application functionality and for the presentation to the user data in diverse different schemas, and then do the kind of merging and fusioning and putting that data together on the fly in the application functionality. So here is also included an aspect that the integrating of data from several models is a part of the application functionality. It's higher level application functionality. It's not a conversion question. It's an application functionality question. The bulk of data comes from others which have taken their native data, which they have created snapshots, and then shared those to you. And for Trimble, we have created a tool to do this, both from the kind of opening these input data sets and to have access to them, and we call this Trimbin. So we have an architecture. I'm coming a bit more into this. Table structures implements this already partly. The data is published as snapshot when you have created it and you use it control. So this is mainly used for this across border contract border scenarios. When you work within a contract border, you can share the native data as Tecla Structures has been capable of doing with total sharing. Many people working with the same native model for more than 10 years, 15 years or something. So when you don't need to manage revisioning and these rights, who can do what as exactly as you need when you go over a control border, you can share the native data. So in effect, we need both methods of sharing. We need this real-time native sharing, and we need this controlled publish-based and revision controlled standard schema sharing. And then we can a kind of new aspect which is popping up more and more is that we need to link together these different data sets. When we have different representations, it's not good enough to have them separate. And now we have a technology to do that, which is the linked data and semantic web technologies, where we can use which we can use on the technology level to make the workflow really work and link these data sets together. I'm coming a bit more later on in the presentation in this. And the interesting point of this is that these link sets can be published separately and independently from the actual data content. So we don't need to, it's again this we don't need to have one source of truth. We can have many sorts of different truths because you need to have that in the real world with as the construction industry works today in the multi-party environment. So here's a schematic of how that could work. So we have the application layer, which has its native data storage. And then we have the kind of published data access, where we have standard data abstraction. We can access IFC, GML, and other standards. And this is what we actually call Trimbeam in Trimble. So through this, we access the standard data, or we can have so that the application layer directly understands the standard formats. So both we are using both within Trimble. And a bit more schematic presentation of how this interdisciplinary workflow works, communication between the parties. So if this is looking now from the point of view of an engineer, so he gets the architect's slab object, and he has in his application functionality, which can take the architect's slab and create his engineering slabs, either fully automatically or manually assisted, or even in some cases totally manually, just using snapping as the most simple integration level. But the important point here, it's not a data level function to do the integration. You could also have several other sources of input here. It's part of the application functionality. It's an application domain because the needs are so diverse, and when we are aiming for design automation, it's very clear that it needs to be part of the application functionality and nothing else. Where it's situated then in the information architecture or let's say application architecture, that's another thing. But conceptually and logically, it needs to be part of the application functionality. And when we run this application functionality, it can also create these links, which are stored independently from the data, so that both the engineer knows from which his objects are dependent, which architect's objects, and this could be, of course, many to many, and the architect knows which engineer's objects are dependent on his. So when making changes, the architect can, using the engineer's published data, check that what is his change going to affect. And this is just on a conceptual level. This doesn't exist yet. So, but this is a concept I have been promoting now for many years, and I hope it will be someday really implemented. So also an important point in this about how to share and what to share data with others is that the native data models are changing quite heavily. So they are becoming more and more intelligent, more parametric. They have rich in algorithms, code, visual programming. So you could say that they are less data and more intelligence, algorithm methods, which means more dynamic. Things which can easily be changed, and you can make big drastic change very quickly to the native data. And this kind of data, where you might have several integrated applications used, like in Structures, we use Grasshopper as the parametric engine, which you can build very powerful models with high level of intelligence, so that the kind of Grasshopper takes care of the high level intelligence, how to move other things, and then the Structures functionality takes care of that, how your detailing lives with those high level multiplications. But this kind of data is pretty hard to consume, because you might need several applications running on the fly, integrated, to have access to this model. So it's much more sensible to publish a snapshot as IFC in this and use that for consumption even within the organization, within the contract border, but specifically when you go across the contract border. I would say that in future this is the only reasonable way to communicate, because the models become so rich in functionality, and it's also not just a technical question of how to share those, it's also very much commercial question, because you don't intend to share that intelligence which you have built into the model. That's your property. You only sell the end result of your the intelligence. And this is the nice thing with IFC, that if we look at the IPRs and how the rights to use the information, IPR is not that different from a drawing, from a human readable drawing, because all the intelligence has been stripped off. So it's a snapshot, and the rights to use are more or less the same as you would have with drawings. So this takes away the IPR issue. And here is a representation of this, how the BIM system is forming. I made this schema already more than 10, almost 15 years ago in Vietnam, of all places, when we are visiting. And it's very clear now that the development is going in this direction. So everybody has these publishing platforms, Trimble Connect, Autodesk 360, Nemetschek, Bentley, and there are also plenty of independent publishing platform or CDE vendors today. And we will have these existing desktop applications like Revit, Tekla Structures, Archicad for a long time too still, but their kind of portion of the software is decreasing, because most of the new consumption softwares will be built on top of these CDE publishing platforms on the new technology. And my prediction has been and is strongly today that this interface won't be standard. There will be a small portion of this which will be standard, but the competition between the vendors in BIM is going to happen here in these interfaces. How to access the data, how much functionality you have in the cloud, what do you have in the clients, and those clients are of course different. You have mobile apps, web apps, all kinds of machine, robots, drones, all kinds of machinery using and accessing the information directly. We have plenty of examples of that already, and this has an implication. It will mean that in any major project you will have many of these platforms utilized. This kind of what you have had with human readable documents, that you have been able to choose one file server or file sharing platform to use for the whole project. That won't happen anymore in this new model, or let's say intelligent CDE world. You will have all of these, and of course then becomes important that these CDEs will have to communicate between themselves and share data. And this standard is already being developed by Building Smart and Sen. So defining these, also this rudimentary access here is being defined and this being defined. So this will happen, but my prediction, and it seems to already be the fact, that in any major project you will have, I would say, all the major platforms in use somehow. Depends how much will vary, but that's a typical, and there are many of these. So then a kind of use case application of how this concept works in the kind of world in the asset management world, and it works, the same concept works. So you need to have an FM system which has its native facility and asset DB, where you store the information which you daily use and modify and update in your facility management and facility operation process. And you create this data from taking the objects from the IFC. You take just some objects, of course the spaces and mechanical equipment are the most important types to have here, and then you have kind of geospatial data and neighboring properties and other things which you get from CityGML, and then you work these, and you also create the links between these so you can find the original data. And when talking about this, that how are these IFCs maintained? Well, they aren't. You can't really maintain these. That's a futile effort. So you put everything you want to maintain in this native system. By the way, this kind of systems don't exist yet. They are still to be developed. I have promoted for a long time. I'm usually an early adopter, so I have promoted for a long time that this kind of system should be developed, but they haven't yet. They don't exist. So you update it here, and when you need to make a new modifications, renovations, whatever, you produce new IFCs from here, and then you take parts of data from the original as-built IFCs and you make your renovation plans, and of course again produce a new batch of up-to-date IFC objects files, which you, or datasets, what you want to call them, which you then keep for reference. So this is the workable solution to this updating problem of data, and works exactly according to this publishing and sharing, or we also call this concept reference model concept, that you separate your data which you own and modify and update, and data which is kind of you get from others, which is just reference for you. Then a bit more about this relationships and links, how to do this. There are several ways of kind of linking together different representations of the same thing. And this one first comparison, well, this is what you could say clash checking is, represents this, that you dynamically compare these. Very dynamic and flexible, requires lots of work. Then you have a kind of fusion idea, that you could have a centralized model server where you fuse the information as a one-time operation and have it stored as one representation. Well, we have already dealt with why that's not a very good thing and easy thing to do. And then you have the third, which is the most dynamic and flexible, which is the linking thing here, which takes this fusion part, that you don't have one way, one method of fusion. Instead, you have many ways, depending on your use case and need and application. You have many ways of using and integrating the data from the different models, and that fusion, that part of application functionality, not data management, to do that fusion. And the service provided by the data management is this linking. So you can store how the data is related, and very importantly, outside of the content of other content of the model. So traditionally, relations have always been embedded in one or the other, or some data set, but now linked data technology gives you the possibility to have those link sets separate, and you can have information management for them is different. So they can be owned by other people than those who own the actual content, and created and edited and updated and maintained by others. And that's a very important aspect, that you have this shareability and flexibility in the information management, because that's what we need in the construction industry. So I won't go into this a bit more. There are many principles, but here, yes, a simple, very simple use case about what I'm talking about in general, that you have several parties, and you can use these links. Important part is that you can have model level links and instance levels links, going down to the instance objects, and that's very interesting. And this is a bit schematic presentation of how you can do that. And here we see that for what is for an architect is a wall. Well, this is already an element, so the architect won't create this. This is created by somebody else than the architect. But then this can in actual even be then split into two pieces or many pieces, or be part of some other piece. So it's a pretty complex situation. And we have done quite a lot of research in this. We have had projects Drum and Run Breathe, and here, if you want to look at those, where we have done academic research on how this could work. And that's here are some links to those projects, which is currently available, the results from those research projects. They were pretty large projects. Also, as a detail, these have to a large extent funded the semantic web or version of IFC. Okay, that was all. Hope this was helpful. Thank you for me.